Okay, I guess we're at time. So good morning all. This is the Openpgp session of the first hybrid IETF meeting. So we'll see how it goes. We have about 30 odd people in the session. We have about a dozen in the room. Um, DKG, you want to say hi?
Hello, I'm Daniel Kahn Gilmore, your co-chair with Stephen Farrell.
So DKG is remote. Given that this is the first session of the week in the first hybrid meeting, we'll expect things to go weird, but so just logistics and so on. There's a place to take notes. There's Jabber. There's also a chat session in the same chat session is in Jabber and in MeetEcho. The next one is yep. Oh yeah. Sorry. If you're here, please do log in to the data tracker because that signs the blue sheet. Is that correct? Thank you, Paul. So again, yeah. So if you're in person, log in to the data tracker, and in theory, yes, in theory, you're supposed to join the mic line via the data tracker. I'm not sure how well it's going to work in practice, but we give it a try. If it gets funny, we can manage it. So if you want to go to the mic, the theory is if you're present in the room, you should join the queue and then go to the mic at the relevant time. In practice, as Paul just did, in practice, we'll see how it works. And again, if you're in person, then again, keep your audio and video off. For remote participants, hello. I hope it's all working for you. Headsets are recommended, as it says. And I guess everybody just be patient because we're all trying to figure out new stuff. And it's the first session of the week, which is the traditional session when things go wrong. The note well, this is an IETF meeting. There's a whole bunch of things you should note well. They're all up there. You will get fed up seeing this during the week. I guess the only thing I'd say is, in addition to that, please read that, be familiar with it. If you're not, get familiar with it. And again, be nice to each other. Our agenda. So we're on the first point, just the administrivia, and just see if anybody has any agenda bash to suggest. Then we'll have about an hour to talk about chartered work. I have a couple of things to say about the design team that's been running. Then Justice, if he manages to get into MeetEcho, fine. I think we'll hopefully have him present the difference between the latest draft and the previous one. And then there's a few issues that the design team felt would benefit from discussion with the working group participants more broadly. And then we have a couple of presentations that, again, the time may kind of shift if those take longer. Falco is going to present some work that's starting on a post-quantum approach to PGP. Is Falco in the room? Oh, sorry, I just forget right now if that's a remote presentation or not. Okay, when we get there, we'll see. Falco,
I'm here remote.
You are remote. Okay, fine. Thanks for being here, remote. Mallory, I'm pretty sure it is remote, and it's an awful hour in the morning for her, as it is for other people in her time zone. So I don't see her in the room right now, but it's a horrible time of the day. And then Aaron has a presentation who's here, and Aaron helpfully has agreed to help us with taking notes. I would like to get a second note taker before we proceed. The MeetEcho tool has a way of allowing you to collaborate taking notes in an Etherpad-like thing. Okay, Pete Resnick is helping to take notes for the dispatch meeting, but that just popped up on my screen. So could we get a second person to help with Aaron take notes? And if not, we'll just stop here until we do. Okay. No worries, Justice. We'll manage. Okay. So waiting for a note taker. You get a second person in the room to help. I guess that would do. Thank you. So do you know how to click the button so if you're using MeetEcho, not the on-site, I think you have to use click the video one to see the note-taking button. Great, thank you. Okay, so that's our agenda. Any agenda bashing? So in particular, I guess we have on the agenda we have the latest ID, where I guess Daniel will go through some of the changes that were made. As he does that, I guess it'll be just. I hope if there's any clarifying questions you ask them. If there are things we want to kind of put for longer discussion later that Daniel mentions during that presentation, then that's a reasonable option to take rather than going into too much detail immediately. So basically, we can take some topics in the latest ID and push them into the issues for discussion as need be. Okay, so anybody remote who wants to bash the agenda, now's the time to jump in the queue for that. DKG?
Observing the members that Eustace has joined.
Oh, great.
So,
yeah, great. Okay, so Justice, we can try to move over to you in a minute. Okay, so yeah, so we have been running a design team basically to try, and there was a whole bunch of work done in the past before the working group was rechartered, so it was quite a bit of work to do catch up on that. The design team has a mailing list that's there. The archive is public. You can actually subscribe to the mailing list and receive mail, but not post. Or you can see the archive. Those are the members there. We have the kind of chairs. Paul Vatters has been helping as an editor, and then a bunch of people who have PGP implementations, which has been really helpful to try and sanity check what we're doing. I guess Werner was only actively taking part for earlier meetings. He just had work conflicts, so couldn't continue. We met kind of most weeks about 29 times. I think it worked well. It was productive. We're hoping to kind of declare victory on that process pretty soon, and ideally then have a draft that we can start a working group last call on. And by pretty soon, I hope that's within like weeks, not months. And if as and if the working group is rechartered to do more work, I think that process worked kind of well. So the chairs would probably adopt it again. So if we do continue to do more work, there will be an opportunity for people to say they'd like to help out there too. And with that, we move on to the current draft. Now, Justice, do you want to take control of the slide movement, or would you like me to do the next slide stuff for you?
I don't know how this works. Maybe you can drive the slides.
Okay, so whenever you want me to go to the next slide, just tell me.
Right. So this is a brief overview of what we changed or what we are proposing to change in Openpgp. Next slide, please. First of all, we'd like to... Oh, you removed the slide.
Did I? Maybe I skipped one.
Who read actually the draft. So I don't know how I get a sense of that, but maybe the room can get a sense of who read the draft.
Yes. So who's read the current draft? Oh, okay. So Justice, I don't know if your audio can be higher or it's a little bit low in the room. So I guess we can use the show of hands tool. Where's the bloody show of hands tool? Oh, thank you, DKG. So again, there's a poll happening at the moment. If you've read the draft, indicate so. Okay, so that seems to have stabilized. We have about 8 people who are kind of up to speed in the draft. And just in the room for my own sanity, because I like that too. How many people here have kind of read the latest draft? 4, 2 of whom are on the design team. Okay. Okay. All right, so about 8 up to speed, Justice. Next slide, I guess.
All right. Yeah, next slide. So let's talk about the exciting changes. And maybe the most important thing is AAD. We had AAD support in the BIS draft, but we changed that up a little. And we decided to go with the version 2 of the SIPD packet rather than specifying version 2 of the BIS AAD packet. Because we thought it would be weird to come out with the version 2 packet as the first version. I get a little bit of echo from the room. Can we turn that down?
I cannot, sorry.
Okay. Well, so compared to the first version of the SIPD packet, we actually have fields on the packet that specify the cipher and AED mode, and we also include a solve. And then we introduced a key derivation step using HKDF, and that gives us two things. First, it authenticates the context, as in the cipher and AED mode, so it provides key separation between different ciphers and AED modes to prevent downgrade attacks. And the per message salt gives us a per message key. So in the future, if you have a OpenPGP message, you can always reply to that message by reusing the asymmetric key material and using a different salt. Next slide, please. So I'm going to go into a bit of detail because if you want to look at anything that we changed, please look at this.
Yeah, how do I get rid of that?
So we start out with the session key, and that comes either from a PKESK packet, asymmetrically encrypted, or from an SKESK packet, symmetrically encrypted. And then we use that as input keying material for HKDF. We get the salt from the version 2 SIPD packet, and as input parameter for HKDF, we use the packet tag, the packet version, cipher and AED mode, and the chunk size. And out of that, we get a message key for the cipher and part of the nonce for the AED mode. Next slide, please. So let's look at how we use AAD. First, we derive the message key using HKDF. Then we derive the leftmost parts of the nonce, also using HKDF. And then the lower or the rightmost 8 octets are a big endian counter, starting from 0. As additional authenticated data, we use the same data as we gave to HKDF as the input parameter. And then we do chunked AAD. Our chunk sizes are powers of 2, ranging from 64 bytes to 4 megabytes. A message contains at least one chunk, and only the last chunk may be truncated. Every chunk is directly followed by an authentication tag. And the last chunk is the final zero-size chunk, which also includes as the AAD the plaintext length. Next slide, please. So here you see sample 4 and 5 messages. On the left you see a version 4 message with an SKESK packet, and notably it contains the cipher used for the SIPD packet as plain text in the encrypted session key. So the version 1 SIPD packet has no fields besides the version, and it only knows the cipher mode to use, or the cipher to use, from the ESK packet. And in that, you find a literal data packet and an MDC packet. MDC packet is OpenPGP's legacy way of authenticating cipher streams. In contrast to that, on the right you see a v5 message, where you have the cipher mode and AAD mode in the safety packet, as well as the chunk size and the salt. So the metadata is in the packet where it belongs. And in that you find a literal data packet and a padding packet, which we will come to in a minute. And previously we kind of relied on the non-malleability of the SKESK or PKESK packet to prevent cross-grade attacks in cipher or AD mode. Whereas in the new scheme, we use HKDF for that. All right, next slide, please. So what's the status? Nibe has implemented that in the branch for GNU-PG, and I've implemented that for Sequoia and generated test vectors with that. I can report that our support for EAX is good, GCM is a bit problematic, and OCD is not as widely supported as we'd like, because it used to be covered with patents. When we look at the ecosystem, we need to start to think about a message API. So if you have an OpenPGP message, you want to be able to reply to that. Next slide, please. Let's talk a little bit about packet versions and how they can be combined, because we've seen that with the site-D version 2 packet, we moved cipher and AAD mode to the site-D packet, so it no longer is in the session key. So obviously you can no longer use the old kind of PKESK and SKESK packets with the new site-D packet. So likewise, we defined a new signature type, and that can only be created with the new kind of keys. And that leaves the question, who can use what kind of packets or features? And we use the same established signaling mechanism, where OpenPGP certificates can have preferences and a feature subpacket, and we can advertise feature or support for the new version in the feature subpacket. Next slide, please.
So just to note on the previous one there, in a Jabber, Werner just points out that Nibe's GNU-PG implementation is not a, what did he say? He said that what Nibe did are experiments to understand the new thing, so it's not an official implementation. He just wanted to point that out, I guess.
Right. So that's true. All of our support is not in the mainline branches yet. And when I say interoperable, I mean we've demonstrated that it works once. Because we started with symmetric encryption, let's stay with symmetric encryption for a little while, because we use the same mechanism. We've seen the SKESK packet, which is a symmetrically encrypted session key packet. In v5 we also use AAD there, and we use the same scheme using HKDF to provide key separation. And we changed the syntax a little bit, and can now robustly parse this packet, even if we don't understand, for example, an AAD mode or an string to key mode. Next slide, please. And the same applies to secret key encryption. So we use the same construction around HKDF, and because we aligned the layout with the SK-ESK metadata, we can also robustly parse this packet now, or encrypted secret keys. Next slide, please. When we look at the key material packets, there is only a little change. We added an octet count to the public key material, and that has the advantage that, given that we have an v5 secret key, we can convert that into a v5 public key, which is needed if you want to compute the fingerprint, because the fingerprint is only about the public key parts. So you need to know how much public key material is there so that you can skip the rest. Next slide, please. We also introduced a new version of the PK-ESK packet. Not much changed there, except now there is a recipient fingerprint instead of a recipient key ID. And as with the SK-ESK version 5 packet, we no longer include the cipher in the encrypted session key. Next slide, please. We also added Argon2 ID as a new method to derive a key from a password. Argon2 is specified in RFC 9106. It has 3 parameters: the number of passes, the degree of parallelism, and a memory parameter. And we expose all those parameters in Openpgp. And both Nibe and me have implemented that, and we are able to exchange messages. Next slide, please. We did a bit of an update for the signature packet. Notably, we have a prefix salt, so there is a salt parameter that is hashed as the very first thing. And there are kind of 3 reasons for that. First, we defend against attacks on the hash function's collision resistance. We used SHA-1 for too long and saw that degenerate. And adding a salt actually protects against attacks against that. Adding a salt also helps against evil web application attacks, where maybe Daniel can say something about that. And while we were speccing this out, there is actually another attack where this helps against, which is a concern where EDDSA is used to compute the same signature twice, and in the second run there is a fault injection attack, and that can lead to secret key recovery. And by making sure there is salt in the signature, you make PGP signatures non-deterministic, so you never sign the same message twice. There is a related change for the one-pass signature packet. If you want to do a prefix salt, you need to have this information early on, so you need to include it in the one-pass signature packet. So there is another change. We also use a fingerprint there instead of a key ID. All right, next slide, please. We included a padding packet. The padding packet is ignored, like the markup packet, but it can have an arbitrary length, and it can appear anywhere. But we give guidance for where to put the packet to increase compatibility with the legacy implementation. The body of the padding packet should be random to protect the padding from any compression layers, like in the transport protocol. Next slide, please. There are a number of general improvements. So we defined how to use MPIs, multi-precision integers, to encode non-integer data, because modern EC algorithms produce and operate on octet strings, which are not necessarily integers. The Openpgp has two ways to express packets, the new and the old way, where the new way was introduced in 1998 and the old one deprecated in 1998. And we kind of made the next step in the deprecation process by calling the old one the legacy format and warning more sternly against it. We have an intended recipient packet in signatures, so you can bind a signing context to an encryption context. And this has been proposed for quite a while, and we included it because it is a cryptographic refresh thing. We changed how certificates look. Notably, they are now valid without a user ID. Previously, certificates had to include one user ID, but there was no requirement on it being actually bound by a signature. And now we made the user ID optional. But there is ongoing discussions, and Daniel will talk more about that. We also switched tool chains. We now operate on Markdown. We use one sentence per line, and the design team worked mostly in GitLab, and that worked well for us. We introduced a lot more tables and tried to bring more structure to the text in general. Next slide, please. Algorithms. So for public key algorithms, there is only you have to do EDDSA and ECDH. You have to do ED25519 and ECDH using curve 25519. That's Openpgp's version of X25519. And you should implement the same using curve 448. If you look at the ciphers, the only mandatory to implement algorithm is AES128. We added the Camellia ciphers and strongly deprecated IDEA, TripleDES, and Cas5. The only mandatory AD mode is OCB. And we also added GCM because it's a FIPS approved AAD mode. Nothing really happened to the hash algorithms. So SHA-256 is mandatory, and it's also used for fingerprint calculations. MD5, SHA-1, and RIPE-MD are strongly deprecated. Next slide, please. KDs and fingerprints. So version 5 fingerprints are the output of SHA-2 and are 32 octets. and the 5 key IDs are the leftmost 8 octets of that fingerprint. This is an area where we spent a bit of time on, but didn't really make any progress. The worry is that the fingerprints will be very long and even less ergonomic than the 4 fingerprints. We don't really have a solution for that, but the consensus is don't display fingerprints to users. Next slide, please. And with that, let's talk more about areas where we are working on or need guidance or want to open up the discussion.
Yeah, so let's. So I think Daniel's going to start with that, but let's first see, are there any topics that have come up that people wanted to talk to on this? And I think there certainly is one that Werner raised about AEAD. So, Werner, do you want to jump in the mic line or just send audio?
Yeah, hello. So,
Hey.
well, I have some concerns. So let me quickly tell a bit about the history. So I think it was in summer or late summer, I dropped out of the design team because for one, I had some time resource problems. And technically, we have finished all the critical questions why this design team had been set up then, and so everything was fine at that point, and only a few things had to be done. For example, MPI, ECC, how to describe the parameters in a better way, and so on, and change some wording and these more editorial things. And things. What I've now seen is that there are large changes, which, So in 2018, in January 2018, 4 years ago, we have started to deploy AEID because on internal agreement in the working group that this is the way we are going with AED. And this has been overthrown by this new ID. That's not good. That is bad for the reputation of Openpgp because it's not reliable, cannot be seen as a reliable working group if things like this happen. These are my main concerns. Having GCM is bad, but I suggested that anyway because of getting FIPS certifications. And there is currently no way to have OCP in FIPS, and also not in the next few years. Okay, that's from me.
So Werner, let me see if I can just understand the concern correctly there. So your main concern is that the current draft specifies AEAD in a way that differs from the deployed implementation in GNU-PG. Is that the main concern?
Are in GNU-PG and in RNP, and we did interoperate testing. We had in the working group we had convent that this is the way to go, and this is the reason why it has been implemented. Now, last summer, things seem to have changed then. In particular, after I dropped out of the design team. If I knew about that, so I would not have dropped out then.
Okay, let's not worry too much about the who and when. I think it's more interesting the what, and the output of the design team is input to the working group. So if there's things that need changing or fixing, that's perfectly normal. I'm trying to understand. Can you be a little bit more specific as to where in the current draft needs fixing from your point of view?
Where you you added new packets, deprecated the old AEID packets, changed the entire structure. So in particular, it's about AEID, which was one of the main goals which have been chartered are here, and that's a real concern. also adding a new KDF is also not a good idea from implementer's view, adding complexity.
So I see Daniel in the queue. I guess you get to stand at the microphone even, Daniel.
Does this thing work?
Can remote people hear Daniel from the room?
No.
Does it work like this? Can you hear me well? Okay, good. Yeah, so I think some of the changes that were made to AAD were a result of adding GCM. And I thought I would just comment since that was partially my proposal. So there was an attack that Lara Brusagini, who is one of my colleagues, pointed out, which is when you have a GCM encrypted message, you can do a downgrade attack by converting it into a message that claims to be CFB encrypted, given that CFB and GCM are very similar modes. You can then sometimes even successfully decrypt the message as CFB if there is a broken implementation of MDC, which has happened in the past. This can lead to a decryption oracle, or rather, if there is a decryption oracle in CFB, you then also have a decryption oracle in GCM. So the concern was that if you can convert a message between different modes, also, cross-grade attacks between different AAD modes, even though we're not aware of any, they might happen in the future. So this is the main reason why we added key separation, and adding an HKDF was the method we landed on in the design team in the end. There are other possibilities, such as putting the AAD mode inside the encrypted public key encrypted session key packet, or the secret key encrypted session key packet. I don't know how much you want me to go into the details, but this is mainly the reason that many of those changes were made, was a result of adding GCM, which in turn was a result of wanting to add a FIPS mode, if that makes sense.
So I saw DKG briefly in the queue and then jumped out. But Werner, I think you should feel free to respond there too, if you wish.
Well, okay. So the better solution is not to have a way to choose an algorithm. So now without the pattern problems in OCB, I would suggest to drop everything else and use only OCB and nothing else. And then better wait for FIPS to get straight and allow OCB. I can't see that right now, but I've seen that brain pool curves are also, or will also go into FIPS. So there is a possibility to have this in FIPS in some time.
So Werner, again, just so I understand, you're suggesting to kind of revert this change, and on the basis that OCB doesn't have the attack problem that Daniel just mentioned.
Yeah, that's right. It's that's one reason, and it is in general better not to have a way to choose between algorithms, and we know that OCB is a good algorithm. I can't see that there will be any reason to replace it. And as we talk about, there's GCM. GCM has so a lot of problems. So okay, put another packet into, if they really want to do this as an optional thing, to have GCM with AAD. But for everything else, we could just live with CFB plus our SHA-1 thing, which is also a solid way of authenticated encryption. also not standardized, but this works and it can be FIPS approved. Can be part of FIPS approved implementation.
Okay. And do we have other people who want to talk on this topic? DKG, I think are you in the queue? You are, yeah.
Yeah, I was in the queue earlier, but I think Daniel Wiggins said what I was going to say about the cryptographic justification for including that. I want to say I think I agree with Werner's general sense that fewer options is better, but I just wanted to know that that would itself be a major change from the draft that existed as of 4 years ago. So, you know, no matter what, any of the approaches, either the one that's currently in the draft or the one that Werner is proposing, would indeed be different from the thing that we never managed to get out the door. This work we never managed to get out the door originally. So, the changes that we're seeing are a result of additional cryptanalysis. Thank you to Lara, who Daniel mentioned, and potential changes in the environment around cryptographic algorithms. Werner, you mentioned changes to the asymmetric choices available for FIPS. My understanding is that FIPS has no current plans to review symmetric cipher modes. I would love it if they did, but we're not working in that world right now. And so these choices, I think, are the product of sort of where the world sits at the moment, to try to ensure that Openpgp has a robust mechanism going forward, both for people who require FIPS compliance and not.
Okay. Do we have other people want to chime in on this topic? So would it be, again, just try and clarify my understanding of this, would it be fair to characterize this as, Werner, as you're saying that OCB is good enough, and while we might want the ability to support different cryptographic algorithms, having the same level of flexibility for modes is something you don't think we need?
Yes, that's right. We put EAX into it and the choose of modes just because some folks had problems with the pattern status of OCB. But as I said back 5 years ago, well, about this time, the patents will anyway have expired. And we are now at that point. And Phil even dropped paying the fees for the patent. Yeah.
Okay. And so I guess I'm thinking, what's the best way to kind of try and figure this out? Has anybody got a suggestion for the best way to resolve this? To maybe, would somebody be willing to create a merge request for the GitLab repo that would allow people to see the affected change, or is that just too much work? I'd have to look at I'm looking at Paul as the editor. I'm not asking you to make the merge request. I'm just asking, would it be a lot of work to make the merge requests reflecting what Werner is talking about?
I'm not sure if I'm in the queue now.
You're in the queue now.
So not on the screen. So I'm not sure if the audio is on, but
yes, no, the room audio goes.
Okay, great. Okay, I just want to make a point. Like, I think this is an item for discussion before we do a merge request, because it's like we don't need the exact text, right? Right now, it's the issue that we need to understand better, whether we want to go with option A or B. I don't think presenting text will add clarification to the discussion at this point.
Fair enough. Since you've been in the editing, I bow to your knowledge. So is the right outcome here just for the chairs to start a thread on the mailing list to see, do we prefer what's in 05 or do we prefer what Werner is kind of proposing? I'll try and, Werner, I might drop you a mail, see if I can properly characterize what you're saying, and then start a thread on the mailing list. Does that sound like a reasonable way to proceed? Yeah, okay. Werner says okay, just as I had. Okay, so I guess if the people taking notes would just make sure that there's an action on the chairs to check with Werner and create that thread on the list. Okay, any other topics on the current text of draft 5 that people would like to raise for discussion just now that are not going to be covered in this other list on the screen? Not seeing anything. Anybody in the room? Anybody in the queue? Nope. Okay, in that case, Daniel, do you want to jump up? And I think apparently the box here is where you should be. The box has gotten smaller since the last in-person IETF.
Very specific. So does this work as well? I guess I'll assume it does until people complain. Okay, so as Eustace hinted at, there has been some discussion and also some proposals within the design team about how to structure a public key or a certificate, what elements to have there. So I'll talk a bit about that. Next slide, please. Can I also do so? Or no?
Oh, beats me.
So. I'll try here.
No, it's not there. No,
doesn't work.
No, you have to ask me.
Okay. Does that thing work? Or?
No.
Okay. All right. So yeah, just to summarize the current situation, there is this convention, let's say, in Openpgp to require a self-signed user ID, where you also store various properties about the key, such as the expiration date, the algorithm preferences, etc. And there are some use cases for not having a user ID. For example,
It'll come back.
For example, keys.openpgp.org has been publishing keys without a user ID when the user ID has not been verified yet. Thank you. In addition to that, we at ProtonMail also would like to publish keys without a user ID in order not to reveal personal data. For example, if it contains their full name and people import their key, they might not expect us to publish it. And in addition to that, we have been getting some attacks, let's say, where people try to enumerate ProtonMail addresses via WKD, for example. So we would like to hide whether a certain email address exists or not, also for privacy reasons. And again, this is easier if there's no user ID in the key. Because the user ID might contain, very specific details that make it obvious that it's not an auto-generated key, for example. Next slide, please. Yeah. So RFC 480, the current, let's say, Openpgp RFC, required a user ID, but does not require a self-signature, as Eustace also said. But by convention, let's say, some implementations did in fact require a self-signature, which has some advantages, such as being able to express an expiration date without an attacker being able to remove the self-signature, for example, since that would invalidate the key. But this has not been documented in the spec. The crypto refresh goes in the other direction by also not requiring a user ID. So there has been some discussion about do we need to require, for example, a direct key self-signature to replace this self-signature. But yeah, next slide, please. So before I get to that, indeed, first the question is, do we need a user ID? Um, so um, when encrypting to a key, you might think that you want a user ID to know whether you're encrypting to the correct key. But I would argue that you anyway need a separate mechanism to verify that. Either you get the key from WKD and therefore you trust that the key belongs to a certain email address, or you get it from a key server and it also has some third-party signatures if you like the Web of Trust model, or there's also a proposal for key transparency, which Aaron will be presenting about later. Or you can, verify the fingerprint in person, or call them up and say, hey, is this the correct key? Um, in any case, just trusting the user ID is not sufficient because anybody can generate a key with any user ID they like. For the second point, when verifying a signature using a key, it's a bit more tenuous because you might argue that you want to know that the key owner claims to be that person that you think um, is sending you a message, for example. Otherwise, in theory, someone else could steal a public key and a signature and send you an email and pretend that they signed it and they came up with it. I mean, you might argue about whether this is even a valid attack, since they can also just sign the same data. But okay, another solution to this would be signing the email headers, or repurposing the signer's user ID subpacket, even if you don't have a user ID in the key. And finally, you might argue it can catch some mistakes if you have a user ID. For example, if you upload the wrong key to WKD, then the sender can notice that they're using the wrong key. But in general, there are not many, let's say, cryptographic reasons for having a user ID, I would argue. Next slide, please. Then to the question of, do we need a self-signature? Um, I would argue yes, we do need it, because if you generate a key, for example, which says I prefer AS256, and then an attacker removes the signature, then an implementation can only assume that you support AS128, because that's the only mandatory to implement algorithm. And so, there's a downgrade attack there. Of course, you might argue then, why don't we make AS256 mandatory to implement? But in the future, the same argument still goes. If, a stronger algorithm or mode is added to the spec, we might want some robust mechanism for signaling support for that, to prevent downgrade attacks. And similarly, if you generate a key with an expiration date of 1 year, for example, in the future, then an attacker can't remove the signature and remove the expiration date if you require having a self-signature in order to use the key. As some current implementations do require, but it's not written anywhere in the spec. So the question here is, should we write that in the spec, and if so, should it be the user ID self-signature as it is today, or as an alternative proposal, should it be direct key signature? Next slide, please. Yeah, so here is let's say a tentative proposal. It's not even, there's no merge request for this yet, but This is just a proposal for discussion here. So the proposal would be make user IDs completely optional. Also make a user ID self-signatures optional, as the current draft indeed does, but then require a direct key self-signature in order to have a place to store key expiration dates and preferences that can't be removed. And then if we care about sender identity, sign it as part of the message, uh, for example, in the email headers. Um, then, um, you know, um, yeah, everybody can look at the direct key signature for the key properties. This would simplify uh, what a certificate, let's say, looks like in Openpgp, and simplify usage, but with some potential downsides if we care about, for example, user ID specific preferences. Um, that's part of the topic for discussion. Next slide, please.
Hang on a second, Daniel.
Yes.
Can you just go back to that proposal? I think
Sure.
it might be missing some context. Um, is this for all OpenPGP certificates or just for certificates with a v5 public key?
Right, exact. That's a very good point. Yeah, so this will be for v5 keys. And indeed, that's also part of the reason why we're discussing this now, is even though you might question, is this even in charter, right? Is this even relevant for the charter of the crypto refresh? And certainly the answer might be no, even though some of these parts are, let's say, crypto adjacent. But since we're releasing v5 keys now, it might be a very good opportunity to say, okay, we make a clean break. V4 keys had this convention, and v5 keys, look differently, and we kind of have a more strict and more clearly defined certificate structure going forward. Yeah, thanks for that point. So yeah, the questions to the working group are, yeah, first of all, indeed, is this even in charter? Do we want to solve this problem, let's say? Of course, the status quo is that, we have some convention that is not documented, that requires implementations, more or less, to generate a user ID with a self-signature, even though the spec doesn't say so. And I would say my worry is that, if we don't do anything, then probably that convention will stay for v5 keys as a sort of default. And then we still have this undocumented convention. Another option might be we document the convention, but we don't do anything else. Or another option is we try to change the convention, or rather the practice, by documenting some alternative certificate structure that we prefer. And so yeah, some of this is crypto adjacent, such as the algorithm preferences. So you might argue that it's in charter. Some of it certainly is not. As I said, v5 keys are a nice opportunity to fix all of this, but certainly also you might argue that it's not in charter and that we should fix it in v6 or whenever. Then the second question is, do we care about user ID specific preferences? Because the tentative proposal would be to only look at direct key signatures for preferences and expiration dates, etc. Just to make implementations simpler and make Openpgp simpler. Certainly, a criticism has been that Openpgp is too complex, and That there are too many differences in what implementations do, and certainly I think it would be good to simplify things. But you might argue that if you have a key that you use both at home and at work, you might have different preferences for the algorithms that you want to use on those computers. I would argue that you probably should generate a separate key in that case. But again, yeah, this is definitely a topic for discussion. And then the final question is, do we care about situations where you um, typically don't include the sender in a signed message? Do we care about someone else stealing the public key and the signature? You might argue, no, we don't care about it because someone can just steal the data and sign it themselves. So perhaps it's not relevant. If we do care about it, we could use the signer's user ID. Um, yeah, those are mainly the three topics I had in mind for discussion, but if anybody else has any other concerns or questions, then of course feel free to bring them up.
Okay, so just to, if people want to talk onto this, then jumping in the queue now is the right thing to do. Just to summarize, then you have so the tentative proposal was applying to V5 public keys,
Yes,
and the default, if we can't figure it out, the default is to kind of just stick with what we have.
I would assume so. Yeah.
Okay. Um, and I guess, yeah, the reason for raising this is that the design team weren't kind of sure what people really wanted. DKG?
Hi there. I'm just speaking with no hats on here as a implementer and maintainer. The complexity of per user ID preferences is a lot, and I really like the proposal that's on the table here for the sake of simplicity of understanding. I think there's a lot of room for, even with this proposal, there's a lot of room for potential misunderstanding of OpenPGP preferences. But the idea of dropping user ID specific preferences is very appealing to me from a simplicity perspective. And I've never actually seen a scenario where I've found the user ID preferences were particularly desired or desirable or reliable. So if this is simpler and cleaner. So I'm a fan. I'm in favor of it.
Okay, other opinions? I mean, I guess I can paraphrase Werner from the Jabber chat. Well, I'm guessing he's kind of not in favor, or in favor of the status quo, I think is what perhaps what Werner would. He did raise the point that hadn't been raised, that I think, I guess Derek Atkins had a use case where there was no room for user IDs, and that was, other than that, I think Werner would argue that they should be a must.
I see.
So that's another argument. And again, Werner, if you want to jump in and send audio, that's fine to do that. Yes, Werner, go ahead.
Yes, we had one idea where there was no requirement for the user ID, and that was particularly to Derek Atkins' requirement. So he put it in, and this was just a discussion thing. And later, I think he retracted this, that it's not really needed. And I think basically he could have lived without being 100% compliant to the OpenPGP specs. So I don't know what the outcome of his project. So it's a couple of years now that happened.
Yeah. So maybe just to point out, even RFC 480, even though it did indeed require a user ID packet, didn't require a self-signature on the user ID packet, which, I mean, if you have a user ID packet without a self-signature, it doesn't really add much, I would argue. Of course, implementations required the user ID self-signature, or some implementations required it. So, I mean, certainly another direction we could go is to put that in the spec, right? Require a user ID and require a user ID self-signature if we think we need them. But um, I I don't know if you have a specific argument, Werner, for whether we need them, or what's your opinion on that?
Werner in the Jabber chat, he did raise a couple of reasons why he thinks that they're needed, and then most recently about a PGP 263 IA requiring whatever. So I think the action on this, we're not getting too much more information here in the room. So I think the action on this is again to create a thread on the list.
Okay.
And I guess the choices are this tentative proposal or the status quo. And if the status quo, we might want to document it a little bit better than previously was the case.
Yeah, either documenting the status quo or even requiring the status quo in the document.
Okay.
That could be an option.
Okay. So I think that's a reasonable outcome for that one. Paul, do you want to take the next topic, or do you want me to? I made the slide, but you raised the topic.
So, so to paraphrase the issue here is that the problem is that when people are checking each other's key, the minimum security requirements to do this securely is more than the vast majority of humans are willing to invest to do this process. And we haven't really come up with a solution, and we don't really know what to do. So that is really the problem.
Or we came up with too many solutions, none of which worked.
No, because all the solutions either don't require enough work by the human and are therefore insecure, or require so much work from the humans that they won't do it, which makes it insecure.
That's what I kind of meant by don't work. Yeah.
So we discussed this a couple of times, and we couldn't really come to something of a solution. So we definitely need working group input from this.
So DKG, you're in the line.
Yeah, I think you could provide a little bit more color for this problem. I don't think there's any concerns within the working group about the on-the-wire use of the fingerprint. And for the changes that have been made in the crypto refresh document, there's no place in the modern formats where the key ID itself is used. On the wire or in calculations, the full fingerprint is always used. For people who are interacting with V4, RC 4880 compliant clients, of course, we can't avoid the 8-octet key ID because that is baked into the V4 PKESK packet. But otherwise, on the wire, we're just talking about full fingerprints, and that's not an issue. The issue here is for the scenarios, like Paul said, where humans are in the loop for verifying a primary key.
Martin.
Hey, so I'm Maarten Aerts. I work for the Dutch Cybersecurity Center, and I have a question around this topic for discussion. So if you say don't recommend any specific form, would the implementers, representative of the design team, expect there to be multiple competing, perhaps, or different implementations surfacing in the user interface? Because I think, well, at least our experience has been that it's been hard enough to get people to use PGP in general. So I was wondering what your thoughts are on the effect of this status quo or recommendation.
So we agree that the effect would be bad because there would be no universal way in which humans would actually be able to verify their keys. So we're not saying that's a good solution at all, but we just can't come up with anything that was acceptable.
So yeah, I understood that. I was just wondering if in addition to not having a good solution, having multiple bad ones would be one step worse. Yeah, and I don't know, but I was just wondering,
No,
given this recommendation, what implementers would choose to do, and whether having them make different choices based on the.
so you're right, and all of this came up in these discussions, but we just couldn't come to an actual solution.
No, I'm afraid I don't have anything useful to contribute other than raising this question. Sorry.
So yeah, that's. Let's not take too much time though, because although I don't see Mallory in the, so we may have a bit of extra time. So go ahead.
Yeah, just to say.
So you, just for the recording, if you state your name before.
Yes. So this is Daniel Huigens again. So my position on this is that we shouldn't show fingerprints to the user, and we should come up with something else entirely, which could look something like, showing a QR code in order to make it easier to verify that you're using the correct key. Of course, it's not a suitable solution in every scenario, but I think, in my opinion, it would be valuable for uh, this working group or a separate effort to look into solutions like that. And that's sort of indeed why I would prefer not to put a solution, not to put a suboptimal solution in the spec now, in order to, keep room to think about the problem more broadly, if that makes sense.
So we have Mallory.
Yeah, I just wanted to follow on actually from that comment. Mine is very similar, which is that I think in terms of user experience or user interface for this, it might be very worthwhile looking at messaging and direct messaging implementations of encryption, because users are already being trained there, and following on from what users expect actually might get you the most. Even if it's not a perfect solution, it will achieve, I think, harmony with, again, good user behavior in that verification actually happens. So what I'm seeing in Signal and other places is actually a long fingerprint in addition to a QR code, but that long fingerprint is visible.
So Mallory, you're saying there that they're using the full length hash output as the only non-QR code fingerprint in various instant messaging things, but I presume they're all doing it differently or with different inputs as well, right?
Yeah, I mean, I'm suggesting actually looking through all the primary messaging apps. I mean, I think WhatsApp is probably the largest in terms of user base. So coming up with a sort of survey of all of the larger ones and figuring out a solution that aligns with that. Because this is a user experience question, I think that would be a valid approach.
Martin?
Yeah, so this is Martin again. So I didn't consider a point Daniel just made, and I think that makes sense to me. That if there's no, if this is out of scope for the current effort and the solution would be something that needs more work separately, then I can understand why you would not make a choice here. It's just, well, the point I raised was made. So, yeah, thanks.
Okay, so so I think would it be fair to say that the sense here is that to be confirmed on the mailing list is that the suggestion of the design team to not recommend a specific form is maybe the closest we've still got, but it would be worth looking at, say, what instant messaging apps and so on are doing to see if anything better might just exist.
sorry, Paul, this does require that there's either a recharting or continuation where we pick up that work, right? Because it's currently not in charter.
Well, so not recommending a particular form is, just to clarify, that's just adding some.
But if we're not recommending anything and we might not recharter, then we have the worst solution of all.
One would, yeah, I would like to see this working group recharter to take on this topic, but I can't, just click a finger and make that happen.
No, I understand. But I'm just saying that there's a dependency here.
I think there's a less optimal outcome possible here, but I don't think, I would argue against making it a dependency that we try recharter before we finish this work.
So, as far as being in scope, security area ADs, we'd be happy to receive some guidance on that. Paul, obviously, you're potentially one of those. But the current charter might have it be in scope to say, when presenting this to humans, we believe that X number of bits of the fingerprint are sufficient for human verification or something along those lines, even if we don't specify how to present those to the user, right? Because there is still this, historically people have used the short key ID, which is just 4 octets, which we know to be insufficient, right? So there is a question about cryptographic usage here that might be in charter, even if we don't get to the human representation of it. Just wanted to point that out.
Roman?
Hi, everyone. I was going to hop on the mic and just cut the non-existent queue with my AD prerogative. So just to clarify 2 things. So first, procedurally, Paul and I have been splitting up the working groups, and I'm going to be the responsible AD for this working group. So you're going to be seeing more of me. And to repeat what I said in chat, I don't actually know the answer, and I would like to be very decisive in this meeting to help the discussion. But I'm just not up to speed on where we are with the working group to make a call here. So I want us to continue the technical conversations, but I would like to defer the in-scope, out-of-scope decision until a later point so I can have a chance to speak with the working group chairs and figure something out. Thanks.
Great. Thank you. Okay, so right, again, so I think what we come down to is it's not a good position. It'd be great if the working group recharters later on to try and figure out a better answer. Meantime, I think we could document some of the security issues around people using shorter IDs, and maybe we don't have an ideal solution to recommend, which is roughly what's on the slide. And was that our last one? Oh, okay. DKG, you had one more topic?
Yes. Sorry, I'm not showing video just because my laptop will overheat if I do. So one of the things that's come up that is pending potential change to the draft is to sort of retcon SHA-1. When I say retcon, that's a term from online fandom where people talk about a storyline that has been changed retroactively to mean something else. So we all know that SHA-1 is on the way out. We would love to see it removed, but as long as we have version 4 public keys in Openpgp, SHA-1 will be part of Openpgp. As long as we have version 1 CypD packets, SHA-1 will be part of Openpgp because it's used in the MDC packet there. It may be legitimate to use in those places, but it still seems potentially problematic because we know that there are collisions and we don't know what else is going to go wrong. And so the thought was that we might specify in the draft that everywhere that SHA-1 is used should use something like SHA-1 collision detection. And there's some links on the slide here if you're interested in learning more about this. It's not exactly a fully specified standard, but basically it says we can detect known mechanisms for collision creation. And when those happen, you can either create an explicit failure, right? There's no such digest for this input stream, or you can return a subtly different result, which would make implementations potentially break and make collisions not collide. So we can, in the draft, say, hey, in the cases where you still have to use SHA-1, we recommend using SHA-1 CD or some similar variation to avoid the known collision attacks on SHA-1. Just wanted to flag that that's there. It should have no effect for people operating over legitimate data, and it will just make a noisy failure for implementations that end up having to tackle data that's potentially made from one of the collision attacks that we know about.
Great, thanks. So, does anybody want to speak to liking or disliking this idea, or to I see a thumbs up in the room. I guess that we should just raise this as a thread on the mailing list and say, do people want to go this way? And if they do, then we can figure a text. Yeah? Nobody disagree? Okay. I think that the action is to create a thread about this. Okay, so then the last slide before we move on to the other presentations is again, the design team, we've been kind of operating well. Also, our editor has gone off to become a security area director, which is a unfortunate future for him. But we won't be able to expect as many cycles from Paul, even though it's relatively straightforward to push buttons. But nonetheless, it requires a bit of thought. So we would like to try and get this finished pretty quickly. There's not many remaining merge requests in the GitLab repo. There are tons of issues, but not all of which are amenable to being represented, or not all of which are in Charter. So we'd like to, the chairs I think would like to try and get some implementation experience with 0.5, and then probably have another draft at least that we think would be ready for working group last call. So the issues we called for resolving today, we'd like to do those as part of that, and as people implement things and check it out. That's, I think, our plan for the next steps. Any input on that? Nobody thinks it's crazy? And then, I think once we get a working group last call started, I think it might, depending on, if that doesn't fall down in flames, then I think it might be time to think about rechartering. But let's not do that till we have a document that's at working group last call at least. And with that, that's our current status. And back to agenda. So I think the next we had present, where's the agenda? Yeah. There's the agenda. Oh, there's the agenda. There you go. Okay, so now we have Falco, then Mallory, and then Aaron. And we have about 35 minutes, so I guess if you guys could be a little bit quick, that would be appreciated. So Falco, did you want to drive the slides, or did you want me to?
I can try.
Okay, well I should stop sharing, and you need to hit the share slides, share preloaded slides button, and you'll find your deck as one of the options.
I have to upload it first?
Yeah, no, I've already uploaded them.
Okay.
So if you click on the share preloaded slides button rather than sharing a screen.
Share. I see. Slides request? No. Yeah, maybe you share them. I don't figure it out.
Something. I think that's me. Okay, so just say when you're on the next slide.
Okay. Yeah, thank you. So, my name is Falco Strenske. I'm presenting to you a project which should be of interest to the working group, because it's one of its aspects is that we're going to do standardization efforts for post-quantum cryptography in Openpgp. So this project is contracted out by the German Federal Office for Information Security on the side of the BSI. On the side of the BSI, Stavros is leading the project. On the side of the contractor, MDG, together with the Technical University of Eindhoven, I'm the project manager. So next slide, please. Yeah, the background is, yeah, as I said, it's contracted out by the BSI in order to progress on the post-quantum standardization. The timeline is we started end of last year, and it goes for 3 years till the end of 2024. So we are doing, we're going to do standardization. So I'm speaking, you have to understand, I'm speaking from the perspective of the project. What's actually going to happen in the working group? That's not our influence, of course, but we have this job to do, to drive forward the standardization of post-quantum schemes based on the selection by NIST that we are waiting now anytime, and also do proof of concept implementations. We are aiming at multi-algorithm key encapsulation methods and signature. Here for the implementation, it will be lattice-based. We'll implement it in Thunderbird via RNP and Botan as the cryptographic library, but we'll also make implementations in GNU-PG and libgcrypt. Next slide, please. So, and for the motivation, why address it now already? So there's the well-known problem for decryption, for public key encryption, the store now, decrypt later, which people might be facing today in certain applications. But also for signatures, we have some applications where signatures cannot be redone efficiently. So the long-term security for signatures is also required. And we are observing that post-quantum cryptography is already entering the standardization phase now. So NIST contest is coming to an end, and other standardization efforts, which I will address on the next slide, are also in progress. Demand for PQC is observed in the field, maybe not like it's people want to use it now, but they are preparing for it, I think, and the demand will grow as soon as standards are there. And the integration has started also in protocols. Next slide, please. So this is just some examples of drafts. I don't think we have to go into everything in detail. There are some RFCs already hash-based, especially in the context of the firmware update, the conscious binary object representation. And yeah, LAMPS is considering to adopt a number of drafts around post-quantum key signatures and encryption, binary data formats. And there's also a draft for the ASIN1 encoding for hash-based schemes. And ETSI and ISO also have the activities, publishing documents on this, giving recommendations already. So everybody has it on the screen. So this just as a bit of more background summary for the motivation. Okay, next slide, please. And maybe one more slide, please. I'll reverse the order here. So the design criteria, just as a summary, we are only starting now. We don't have any content to present now what we are going to do. But the aim is, of course, not only to have PQC, but to have this what is sometimes referred to as hybrid, but more accurately probably as multi-algorithm scheme. So we want to be able to have keys, different keys, which is of course already possible in an Openpgp certificate. So you can encrypt keys, encrypt messages with multiple keys of a recipient. You can perform signatures with multiple of your own keys. And so in order to provide this fallback, if the new PQC schemes turn out to be not as secure as expected. We want to orient towards existing proposals, standards as far as they exist, and that makes sense for Openpgp. And we also aim at backward compatibility. So for the key formats and the signature formats, especially where it's possible, where it should be possible, we want the new formats to be ideally processable by existing implementations that don't support the new PQC standard. Okay, one slide back, please. So the timeline here and the whole project line in a very brief summary. We're now entering the phase where we make a design, a proposed design, also more or less in parallel proof of concept implementation. We target to produce a first draft version in the last quarter of this year, towards the end of this year. But in general, our standardization efforts last until the end of the project, which should very well cover the NIST standardization phase, which, as they announced it, as I understood it, should last until the end of 2023. So by then we should have the standards. Only by then, of course, it makes really sense to finish the Openpgp standard as well. But there are many things. There are not many things that are left open now. I would say more or less it's the parameters. NIST will have to specify maybe the APIs as far as that is relevant. But otherwise, of course, it's possible to already start with many specifications at this stage already. Okay, then next slide, please. Yeah, then of course the most important aspect, and this is why we're presenting here, is that we of course seek the cooperation with the working group. We are well aware that there's no charter for this currently. But in any case, as I said, it's a project. It has a timeline. We have work packages. We'll do these things, and the more we have cooperation with a working group, the more I think, of course, this project will benefit. So we are open for any kind of input or contribution, and yeah, currently our plan is to work on a draft, which is hopefully later adopted by the working group. That is from my side. Thank you for your attention. Thank you for this opportunity to present the project here. Yeah, and I'll be happy, or we'll be happy to answer any questions you might have.
Great, thanks, Falco. Florence?
Hi, I'm Flo, UK, NCSC. I was wondering if you'd given any thought to algorithms yet, beyond lattices. Also, thanks, it was a really interesting presentation.
Yet regarding the algorithm choice for standardization, we plan to orient towards the NIST decision. So basically we would like to standardize all, or let's say consider all the NIST schemes that are selected for standardization, also for standardization in Openpgp. It's only that the implementation that we make in the project is restricted to the subset of one encryption scheme and one signature scheme. There's, of course, an interest of us that there are other contributions in all these efforts, that hopefully there is some more contributions of implementations, maybe of the other schemes, as there are already existing implementations of all schemes that shouldn't be too difficult to have a proof of concept implementation of each. But yeah, this is something that would require more cooperation with other people.
Thanks very much.
Thank you. Aaron?
Can also open my camera. I totally forgot.
And also at Proton Mail, we're now trying to consider experimental implementation of post-quantum cryptography, and we have looked at the schemes you also proposed on the mailing list. They look practical and convenient, and we're starting on right now onto let's say proof of concept implementation as well. We would like to, let's say, have a chat and probably develop something that is interoperable, probably.
Yeah. Oh, very good. Yeah, then we should get into contact. Yeah.
Okay.
Great, thanks.
Thank you for the presentation.
Yeah, thanks, Falco. So I guess this would be definitely one to consider at rechartering time. So, okay, I don't see anyone else in the queue. So, Mallory, if you'd like to jump in, do you want me to share the slides for you, or do you want to do it? You're doing it yourself.
I think I can manage. Yeah. I'm not sure if you have to approve my request.
Do you want me to should I do them from here?
I've requested permission.
Oh, sorry, yes. I have to click yes.
Yes, I do.
Pardon
Okay,
me.
great. It doesn't like that.
Oh, okay.
For the sake of time, maybe you should.
Okay.
Oh, right.
I think that's me doing it now. Is it?
That's fine. I appreciate it. All right.
Okay.
Hi, everyone. I'm Mallory Nodal. I'm one of the authors on this draft. It's a definition for end-to-end encryption. And next slide. I wrote it with a few other folks that you'll see here. I'm not sure if any of them are in this meeting, but if you are, feel free to jump in or correct me in the chat, things like that.
Don't see anyone.
I don't see them either. That's fine. Next slide. So the goal is really quite straightforward. It's just a definition of end-to-end encrypted systems, end-to-end encrypted communications. You know, that second part is swapped around throughout the draft. But really, yeah, it's really intended to be very straightforward. Next slide. So why we're presenting it here. So the history of the draft, the first version we were working on in messaging layer security. But when we discussed it, folks made the keen observation that this would apply to other working groups in the IETF, and so it probably should be dispatched. We did that, and the outcome of that session was the security area directors are really kind to give us a mailing list to work on this draft. So you can now review the draft at e2ee at ietf.org. There's been a little bit of discussion there. We got new issues out of those discussions. But then in needing to progress it, I think it does also make sense to for me to come to you, to the working groups that this actually might affect, and ask for reviews. So that's what I'm doing now. I don't know that this should be adopted necessarily in any of these working groups, but more reviews is always required. So next slide, please. To get more into the substance now. The outcomes that we're hoping for with this draft is that it makes it more difficult to call things end-to-end encrypted when they really aren't. And actually, we do see this tendency. Maybe it's not so much in engineering spaces like the IETF, but encryption has landed in the mainstream and the more public discussion about user expectations on the internet and the apps they use. And we are seeing a tendency for that public discussion to discuss things that are not actually end-to-end encryption as if they are. It would be very useful then to have sort of plain language explanation of what end-to-end encryption is from an authority like the IETF. So that's the first outcome. I think it might also be useful, and this is a question, I guess, to this group, to put sort of definitional text in one draft so that it doesn't make your other drafts very long. And you don't have to worry about being really specific what you mean when you invoke things like deniability or other kinds of concepts related to this. And then the last one is maybe a goal. I'm not sure. This is maybe a question for those sort of working across these spaces in the IETF, so area directors essentially, but like, if there's a possible goal or if it is a desirable thing to try to harmonize a sort of norms or principles driven approach to end-to-end encryption in particular, although transport encryption might also have some overlap there. So those are the three outcomes. There may be more. Those are the ones we articulated when we were initiating this work. Next slide, please. Also an important approach that we wanted to be clear about from the beginning is that we didn't want to write a draft that explained what end-to-end encryption is not. That would not have been helpful. Although there are very many examples out there that we could have used, we wanted it to be a definition that stands on its own without counterexample. And to that point, also then invoking threats as a way of explaining what end-to-end encryption is would be a common tendency, and a lot of documentation sort of out in the wild talks about threats when it's trying to talk about encryption. We also didn't want to invoke threat model into this discussion at all. And then the other thing, which this maybe is difficult to avoid, we have no control over it, is that if there seemed to be a lot of disagreement within an engineering space like the Internet Engineering Task Force, that could be counter to our goals to try to come up with harmonization on what is end-to-end encryption. So if we all sort of disagree about what it means, then that's actually counterproductive. And considering IETF meetings and mailing lists are well documented, that would maybe not be useful. But we, again, can't control it. And if we're totally wrong about what is end-to-end encryption, then that might happen. Okay, next slide. This should be the table of contents. Yep. So this is what the table of contents looks like now. It did not always. We've added quite a lot into the formal definition piece. So it's a three-part draft. It tries to define end-to-end encryption in three different ways. And we believe in aggregate, that is what is required to actually come up with a full definition. The first way, of course, is a formal definition. What is an end? What is the end-to-end principle? What is encryption? And then can you summarize that in 1 or 2 sentences? And we do that in the first part. But then I think it's also incredibly useful to look at what are the features of end-to-end encryption, and then what are the challenges that features or implementations are trying to overcome when looking at systems design. So the second part is from a developer's perspective, what is end-to-end encryption? And then finally, user expectations should matter quite a lot, because if the users are not aware of features, or they are not sort of making choices, we were talking before about user behavior around checking signatures, like all of that actually matters quite a bit, no matter what the tech is that's underlying it, because at the end of the day, users are the ones writing these messages and receiving these messages. So user expectation tries to lay out sort of when a user hears that a messaging app is end-to-end encrypted, what actually should they expect, and does the technology fulfill that? Next slide. So the draft is now in 02, I think. So since the first draft, we had to really expand the formal definition section. It was too succinct, and there was a lot of question about what is an end. That was a really interesting discussion, because it's not maybe just the device. If you have, for example, proposals that say if you just scan the device before content is uploaded, then you could do some degree of content moderation in end-to-end encrypted systems. We kind of feel like that's a violation of the promises of confidentiality and privacy in end-to-end encrypted messaging. So then what is an end? Is end is a device? Is it the operating system? Is it the person? What is that? So we dealt with that after the first version. And then the version we're at now has changed. Again, like a little bit more work on the definition, the formal definition section, and also having to grapple again with this identity versus endpoint piece. So those are the changes, actually. It's mostly been in those sections. I think the pieces around, what do users expect, and then also what are some of the possible features for end-to-end encrypted messaging implementations have not really been touched. But that actually might be the ask for you all if you take a look at this. So next slide, please. We're hoping to close a few of the smaller issues in the next version. They're not terribly thorny. I think that it's worth looking for people who really are working on the sort of metadata reduction angle, which sounds like a lot of you are with respect to getting rid of user IDs and other kinds of things. That could use a nice sweep over for folks wanting to review, to like, are we treating the metadata problem enough? As far as I remember, it's just like one sort of subsection in section 2. I think that we have other features in there like perfect forward secrecy, backwards compatibility issues, disappearing messages, deniability, but we want to make sure that that's complete, actually. Even if not every implementation has those features, we want to make sure that they're all there. And yeah, just if we could have more reviews, I'd really welcome that. Next and final slide gives you all a pointer to where this is happening at GitHub. But again, and I should have put this on the slide, I'm really sorry, you can email e2ee@ietf.org with your review. And it would just be really great to have more reviews. But open to your thoughts and feedback now as well, if you have any.
Great, thanks, Mallory. Any comments or questions? I guess how many people have read this draft, or just in the room? No hand. Okay, so I guess we're encouraging people to read the draft. Is the next step really? Don't see anybody in the mic line. So yeah. Again, I would encourage you to read the draft and please comment on the E2EE list.
Thanks a lot.
Great, thanks, Mallory. And Aaron. This is your box.
Oh, thank you. So I'll be presenting Key Transparency. That is a project that we've recently been developing at Protomail, but it's also something that, in my opinion, is very important for the whole community to have an idea, to propose an alternative to verify other people's keys in an automated way. Mind going to the next slide, please? So the base principle is the fact that when you get a key, this key might not be authentic, and trusting the user ID is not just sufficient to know that the key belongs to someone. This is especially relevant for WKD, because WKD servers might serve the key and also handle the delivery of the email itself. So you have a single point of failure where a malicious actor might inject a bad public key, read the message, and silently re-encrypt it to the recipient that might not even notice that this is happening. So, oh no, that's too many slides.
Oh, too many clicks.
Don't spoil the content. So what do we have right now is mostly either a key signing parties or the web of trust. We have seen that these has worked, but this not always works. So we would like to propose an alternative, or at least to look into an alternative that allows people to automatically do this without any manual intervention. Next slide, please. What do we do is basically create a screenshot of the various key in a point in time, and you would basically check whether your keys are into the screenshot, and if you see your keys correctly, everyone else sees your keys correctly. This is, based on the Chronix paper that has been published in 2014, and also Google's key transparency project. So it's not nothing, let's say, terribly innovative, but it is still a good application to Openpgp. So the general principles is the fact that we return you some information when you try to fetch a key, and we return you also, let's say, a revision, a proof, and this, if everything matches, then you can use this information to verify that what you're getting is what everyone else is getting. There is also something needed, is like auditors that verify that we publish consistent epochs and we don't cheat in publishing several epochs at the same time, like basically branching off. Next slide, please.
So, and I just added myself to the queue to ask a question.
Oh, yeah.
In this slide here, who is we?
So as of now, it is Protomail. But the idea is the fact that everyone could run their own implementation of key transparency. There could be, let's say, any kind of, like anyone who wants to participate into the project might want to register their own Merkle tree into, oh, I'm spoiling the content.
Oh, okay, no, go ahead, go ahead. Okay, so Protonail or somebody similar.
Yeah, exactly.
Okay.
Like, also, I don't know, keys.openpgp.org might want to do the same.
Okay.
And how do we do it is Merkle trees. Basically, this is a compact way to simply ensure that users can verify their own path without having to download the whole tree, and auditors can verify that the tree is consistent across epochs. We use verifiable random functions to derive the path of the leaf, and so that you can map a single address to a single leaf, and we cannot cheat by assigning an address to multiple leaves. And, well, here this is an idea, but there might be the fingerprinter that states which key do you actually want to use as primary key. We, in our implementation, are considering using actually not the fingerprint, but a list of keys, because a key ring might be more interesting. Next slide, please. So what do the clients need to do is to verify that their own path matches to their own key, so that to ensure that everyone is seeing their key. If the verification fails, this should be displayed to the user somehow, but this is also most likely left to the client implementation. Next slide, please. And the auditors must verify that the epoch IDs are like consecutive, the chain does not branch, and via gossiping that the chain hashes match. So they should pretty much ensure that the tree is consistent. Next slide, please. Okay. So how does this fit into Openpgp? It's mostly, I think this is an augmentation of WKD. It's something that automatically with WKD could provide us a better key safety, and maybe one day it could also be integrated into keys as an additional signature or additional information saying this key is into key transparency at keys.openpgp.org, or some information like this, like TLS is doing with TLS certificates, that they say this certificate has been released. Is there any question?
So we have DKG in the queue, and then Paul, and then me, probably.
Thanks for raising this. It's I think this is interesting work. I'm curious about your choice of fingerprints being at the leaves of the tree as opposed to full certificates. Basically, because as we've talked about already today, the Openpgp certificate format is composable. And one thing that a malicious WKD server could do is serve up the wrong combination of packets associated with a single public key. For example, they could serve, say, an encryption capable subkey that they know has been revoked because it's been compromised, but not serve the revocation the revocation signature. And this wouldn't identify that particular combination is no longer valid, right?
So in our implementation, we actually consider this. This was, let's say, a toy example where we use the fingerprints, but actually in the let's say final draft that we're trying to implement, we do have a sign key list where we specify also all the sub-key fingerprints and not just and also the usage of the key. So if a key is revoked or if a key is used to be encryption only or signature only, etc., etc., etc.
So sorry, let me. Is this is a whole new data format then that you're
Yes.
defining?
Yes,
Is there a reason to do the whole new data format?
It's an arbitrary data format as of now, but I mean, as soon as we can get to a standardization, let's say, as if we can get this into an RFC, we probably won't use our proprietary standardization, our proprietary standard, but we will try to look with the community what exactly is needed in the different use cases.
So I think the only thing that I mean, we already have a standard for how certificates look. The one thing that's missing for your purposes here, I think, would be a canonicalization of an existing OpenPGP certificate, right? A transferable public key form? Or are you thinking that it needs to be something else?
Yeah, I mean, at least our specific case has also like a little bit, we need a little bit more flexibility. So that's why we implemented this format, but we're willing to, let's say, adapt to what the community then requires.
Okay, I want to get out of the queue here, but if you could describe at some point what specific flexibility you need that's not in the already too flexible OpenPGP public key format, that would be great. Because I don't understand those differences.
Maybe a stupid example could be we have external addresses that are not meant for email use, and we want to specify this directly into the Merkle tree. So clearly, this could also be like this can also be set into the key flags, but the key flags are not specifically into the Merkle tree, and therefore. I don't know whether this notation would include that information directly into the Merkle tree.
Okay, Paul speaking. So my question is about, so I understand the Merkle tree and the append-only properties, and those are great, but who says that the latest submission is actually the real one? Like, we have a whole spam problem in the key servers right now, where anyone's submitting stuff, like, without confirmation. So how do I know that, like, the paul@noats.ca last entry in the tree is actually the real key and not some fake key?
So first of all, this project as a whole doesn't really prevent someone from like faking keys, but makes them identifiable, like makes a problem clear, like gives accountability. The fact that only the people like if we use WKD, if we bind it to WKD and not to the key servers, that would actually give us a lot of, let's say, flexibility in this order, in this direction, because WKD, you have already an authority, like who owns the domain can choose what goes in there, not everyone.
Right, but so who owns the domain? And that was my next question, actually. If you link it to the domain, then you have at least a guarantee that whoever controls the domain hopefully is also within that domain controlling the key, and you get the right person. So if a domain is sold to somebody else will run DNS and point to another WKD service where you can get the key. Of course, if you do that, I'm the author of the OpenPGP key RFC. You can also just put it in DNS and protect it with DNSSEC. Then you have the same property of having the current domain owner clearly owns that key that they currently publish, and it's valid, and it is the latest key because that's the key they're currently publishing. And you would avoid these, at least these Merkle tree things and having multiple keys. With WKD, I don't like it because it adds an additional problem or an additional step where a web server can be compromised and other content can appear.
I mean, this also provides the fact that this lets you look into the past and see if an email in the past was already, let's say, was faked. and also would allow you to see if someone else has published a key on your behalf without you knowing. Like you can audit yourself. That's the whole point of the thing is you should audit yourself into the Merkle tree and spot if there's any inconsistency.
So we're kind of at time.
Oh, okay.
So, in fact, we are at time. Okay, so I guess this is a topic that CT was interesting. There might be a useful way of making this work, and in that case, that would be interesting. I think having a worked out thing like this at the time we start talking about recharging might be quite good.
It's something comes later. Yeah.
Great. So thank you. Thanks to Aaron and to Florence for taking notes. For those of you in the room, you should hopefully have signed into the data tracker and clicked the on-site for this thing. So that's how you sign the blue sheet. So I won't be doing the traditional thing of running around the room with blue sheets at the end as normal. And with that, thanks for coming. And we'll have some discussion on the mailing list and go from there. And thanks to all the remote folks for turning up as well, especially if you're in a painful time zone. And I think we're done. Thank you. So the question I had about the transparency thing was, one of the nice things about certificate transparency is that the CA is included and enforced the law by the browser. So it was a case of the browsers forcing them to do that. The browsers told them, if you don't do